It's the late 21st century, and 500 kilometers above the surface of Earth, we approach a space station. Perhaps we're tourists spending a weekend in orbit. Or maybe we're in transit to the Moon or Mars. For that's where the space station scores, as a spaceport. To launch a craft to the Moon or the planets needs an escape velocity from Earth of 40,000 kilometers an hour. From here, it takes a fraction of that energy. Our attempts to beat gravity began with rockets, invented by the ancient Chinese. The fuse on modern rocketry was lit by the American Robert Goddard. Goddard replaced solid fuel with liquid. From Massachusetts in 1926, he launched the first liquid fuel rocket. The Germans pushed forward development in World War II. As a weapon of mass destruction, they unleashed the V-2. It was the brainchild of Wernher von Braun, captured with fellow scientists and shipped to America. There, at White Sands in New Mexico, working with the military, von Braun galvanized American rocketry and reached to the edge of space. But the Soviet Union got there first. In 1957, they launched Sputnik 1. The first artificial satellite was in orbit. Its mastermind was Sergei Korolev. He was moving fast, developing a rocket powerful enough to carry a man into space. That man was Yuri Gagarin. On April the 12th, 1961, Gagarin blasted into history. He made one orbit of Earth and returned a hero. The Soviets were on a roll. In 1963, Valentina Tereshkova became the first woman in space. Next, 2 men, then 3 were in orbit together. And in 1965, the first spacewalk was by a Russian. Following a series of unmanned flops, Alan Shepard was the first American in space. But his mission, a month after Gagarin's, was a modest suborbital hop. Nevertheless, with a safe splashdown, American pride was restored and the stakes were up. President Kennedy declared the thrilling objective.
Before this decade is out, of landing a man on the Moon and returning him safely to the Earth.
With this astronaut, the race was on. Atop a Redstone rocket and 10 months after Gagarin, America had its first man in orbit. John Glenn. Concerned, though, as a light warned of a loose heat shield. Glenn had a rocky ride. But he made it. And America was in the space race. 2-man missions began in 1965 with the more powerful Titan rocket. Including the first American spacewalk, this was the Gemini project. 10 flights that tested rendezvous and docking procedures. With the Moon the objective, invaluable experience. Gemini 8 in a spin, through a misfiring thruster. But luck held, and the craft survived. In 1966, the Gemini project successfully concluded. These astronauts had no such luck. In a launch pad fire, they died in their capsule. It was a tragic start to Project Apollo. But after lengthy modifications, missions resumed. Separating from the upper stages of its rocket, Apollo 8 became the first craft to break free from Earth and slot into an orbit of the Moon. It was Christmas 1968. As the triumphant crew returned, everything was now tested for a landing, except the lander, and that was tried in orbit by Apollos 9 and 10. Neil Armstrong, Michael Collins and Buzz Aldrin. The crew of Apollo 11, thrust by von Braun's baby, a Saturn V rocket, towards the Moon. 3 days later, the lander left lunar orbit for the craters below. While Collins orbited in the command module, Armstrong and Aldrin made a perfect landing. They'd reached the magnificent desolation of the Moon.
It's one small step for man, one giant leap for mankind.
It was July 1969. Blasting off for the command module, Armstrong and Aldrin rejoined Collins and headed home. With 5.5 months to spare, they'd achieved one president's deadline and had the thanks of another. 4 months later, Apollo 12 was on the moon, a pinpoint landing next to this unmanned surveyor. But next up, Apollo 13 had problems. An explosion crippled the service module. Everything except basic life support was switched off. Mission Control devised ways of keeping the crew alive. And by using the lander module as a life raft, they made it back, but minus a moon landing. Later Apollo missions were less about flags and footprints, more about signs. There was exploration by Lunar Rover and the collection of over 1/3 of a ton of geological samples. Apollo 17 left the moon in 1972. Since then, no one's been back. Instead, America launched Space Shuttle. As a reusable vehicle, the aim was to cut ferrying costs into low Earth orbit. The Soviets stuck with expendable and simple rocketry. They built orbiting space stations, like this one, Salyut. Back in the 19th century, they were the dream of the Russian Konstantin Tsiolkovsky. He'd have loved the Soviet station Mir, begun in the mid-80s and the largest ever built. Aboard Mir, crew from many nations learned to live and work together. Eventually, the Americans joined in, with shuttle missions to Mir. Now we have the International Space Station, but it's much delayed and over budget. This could be the future. An aerospace plane that slashes all previous costs. Its trick is air-breathing engines. They suck oxygen from the atmosphere to burn hydrogen fuel. That saves carrying oxygen and an enormous amount of weight. Only approaching orbit do conventional rockets kick in. From airport to orbit in 10 minutes. Compared to shuttle or a Russian rocket, a budget ride on a lightweight ferry. The station could be an interchange for onward flights to the moon, just a couple of days away. Bulk transporters would ply from the space station with supplies too expensive if lifted directly from Earth. For the moon is now colonized. It's the second half of the 21st century. From lunar cities, we're mining the riches of this world next door. Again, from our orbiting spaceport, an express trip to Mars. Designs already exist for nuclear-powered rockets that will cut the voyage from 9 months to 6 weeks. The red planet will be our home from home, but it'll be life in a bubble, self-sustaining biospheres shielded from a hostile exterior. Much farther in the future, in craft we can only imagine, we may head for the stars. But to leave behind Earth, the moon, the planets and the sun, and traveling at 1/10 the speed of light, it would still take 40 years to reach the nearest star. So how long to a star, with a planet like our own? Maybe this is a more immediate prospect for an escape from Earth. A tower rising 36,000 kilometers from the equator. The idea of space guru Arthur C. Clarke. The tower is one of 4 elevators to orbit, the spokes of a gigantic wheel of which Earth is the hub. Clarke's wheel is both an orbital city and a springboard to space.